This is higher homework 11 and we're looking at question 10. What we have here is we've got P is the point, 5 minus 3, 4. Q is minus 21, 29, minus 20. Find the size of angle POQ. Okay, so let's draw that down first of all. So what we've got is just an angle. So an angle like that. And what we're going is we're going from P to O to Q. And remember, O is 0, 0, 0. That's just the origin. Okay. P we've got is 5 minus 3, 4. And Q is minus 21, 29 and minus 20. Okay, and whenever I work this out, what I need to do is I need to make sure that if I'm trying to find an angle here, I need to find out the vector that's going away from the vertex and away from the vertex there. Okay, so first things that I'm going to work out is I'm going to work out the vector OP. So OP is going to be equal to P minus O, which is going to be in component form. So I've got 5 minus 3, 4, and I'm going to subtract 0, 0, 0 from that. So that will leave me with 5 minus 3, 4. I'm then going to work out the vector OQ, which will turn out something similar. So OQ is just Q minus O. What I've got is for Q is minus 21, 29 and minus 20. Subtracting zeros from it should just leave it as it is, minus 21, 29 and minus 20. Okay, so there's the vectors in component form, which I need. Right, so what I'm going to do now is I'm going to look at the formula, look at the formula sheet for the angle, or for this here, and what I can do is I can rearrange the formula to come out to be, I'm going to work out the cosine of POQ, and that's my angle, and it's going to be, so I'm going to go with OP on the top and OQ. Okay, so that's the dot product on the top, and I'm going to divide it by the magnitude of OP times the magnitude of OQ. Right, so that's it set up, that's a formula set up to work this through, and all I'm going to do is keep it together. Your teacher may ask you to do these things all separately and gather them together at the end. I'm just going to keep them together in the one sum that I'm going to do here. So, OP OQ dot. Okay, so the dot product or the scalar product of these, I can look at the formula sheet again and I can find the formula to work that out. All I'm going to do is I'm going to multiply these together here. So I'll get 5 times minus 21, and I'm going to add to that minus 3 times 29. I'm going to add to that 4 times minus 20. What I'll get on the bottom, I'm going to go for the first one. I'm going to put for the magnitude of OP, it's going to be 5 squared plus minus 3 squared plus 4 squared. And then I'm going to multiply that on the bottom again by the magnitude of OQ. So OQ is going to be minus 21 squared plus 29 squared plus minus 20 squared. Okay, so that's the work that I'm going to do, and what I'm going to do is I'm going to work out the top and the bottom separately. So on the calculator, if I work that through, that's going to be minus 272 on the top. On the bottom, I've got root 50, and on the bottom here, what I've got is 1682. Yeah, 1682. Yep. Okay, so from there, what I'm going to do is I'm going to work out what the angle is. So POQ is going to be equal to the inverse cosine of this here. And all I need to do is just put that into my calculator. If I can put it in correctly, then I'd be able to work that all the way through and get my final answer. Okay, so put that into the calculator. And press the equal sign. So I press equals. So what we have here is, if you can see that, so I've just put it in as fraction mode, and on the top I've got the minus 272. The roots here multiplied together on the bottom, just in the whole bracket, gives me 159.7. So that would be 159 0.7 degrees. That's to 1 decimal place. Okay. What I could have done is I could have worked out this separately, and if I had worked that out separately, I think that's going to be 3/8, and I could have put that in as the inverse cosine to work out the angle that's there. So I know that when that's a negative, I'm going to get my answer. The answer that I'm going to get is going to be in this quadrant here, and it's going to be working from there through to there. So it's going to be an obtuse angle. I'm not interested in the angle that's in the fourth quadrant that's there. I'm only working from the angle that's from the OX round to where my angle is there. So that's 159.7 degrees, and that's it concluded. Right, so let's go for the marks for this question here. I'll go for 1 mark for setting up this equation here, okay, or the formula. 1 mark for getting the top bit, 1 mark for getting that one, 1 mark for getting that one. So that's 4 marks so far, 1 mark for getting the final answer. So what we've got is a question here out of 5 marks.